Could a type the third civilization build this? There is a number lurking in a 1964 physics paper that should terrify you a little. 10 to the 36 watts. That is the entire energy output of every star in the Milky Way, all 400 billion of them, burning at once. And according to Soviet astronomer Nikolai Kardashev, that number is not just a measurement, it is a finish line. A finish line for a civilization advanced enough to capture and use the energy of an entire galaxy. So today we are asking the obvious, slightly insane question. Could anyone actually build that? Not power a planet. Not power a star. Power a galaxy. Let's start small, because even the small version of this is already absurd. In 1964, Kardashev proposed 3 tiers of civilization based on one simple metric: how much energy you can get your hands on. A Type 1 civilization harnesses all the energy hitting its home planet, something like 10 to the 16 watts, roughly what Earth receives from the sun in a given moment. We are not even there yet. Humanity sits somewhere around 0.7 on this scale, technologically still fumbling with extension cords plugged into fossil fuels and a little sunlight. A Type 2 civilization graduates to harnessing the entire output of its home star, around 10 to the 26 watts, which is roughly 400 quadrillion times what all of humanity currently uses in a year. And a Type 3 civilization. A Type 3 civilization eats the whole galaxy, every star, every photon. 10 to the 36 watts of pure, harvested starlight. To get a feel for the jump, imagine Type 1 is a kid with a lemonade stand. Type 2 is Amazon. Type 3 is something that owns every economy on every continent of every planet across 400 billion solar systems simultaneously. So how would you even start? You would start exactly the way physicist Freeman Dyson suggested back in 1960, by going after a single star first. Picture a swarm. Not a solid shell like the old science fiction version, but millions of independent solar collectors orbiting a star at different angles and distances, like a cloud of satellites thick enough to intercept a meaningful fraction of the star's total output. Building this around our own sun would require dismantling something with serious mass, and the obvious candidate sitting right there is Mercury. Disassemble Mercury. Turn its material into trillions of solar collectors, and you could, in theory, capture enough energy to power a civilization 1,000,000 times larger than ours is today. That is Type 2, just barely. But a single star, even fully wrapped, caps out around 10 to the 26 watts, and a Type 3 civilization needs 10 orders of magnitude more. So what is the next move? The next move is you stop building around stars, and you start moving them. This sounds like science fiction, but it has a real name: a Shkadov Thruster. Proposed by Russian scientist Leonid Shkadov in 1987. Build a massive mirror on one side of a star, reflect a portion of its own radiation pressure asymmetrically, and over millions of years, the star itself drifts in a chosen direction, dragging its entire planetary system along with it like a sailboat made of fusion. Why would anyone bother moving a star? Because if you are serious about reaching Type 3, you do not want to wait for stars to come to you. You want to herd them, gather them, rearrange an entire galaxy's architecture to suit your energy needs. Now here is where it gets genuinely dark. Every Dyson swarm you build is not just collecting energy, it is also venting it. The second law of thermodynamics does not care how advanced you are. Any structure that absorbs starlight and uses it for computation or industry has to dump the leftover heat somewhere, and it dumps it as infrared radiation, which means a Type 2 or Type 3 civilization, no matter how it tries to hide, would theoretically glow in infrared like a slightly too warm light bulb sitting where a star should be. This is not speculation. It is the actual basis of a real search. In 2015, astronomer Jason Wright led a project called G-HAT, the Glimpsing Heat from Alien Technologies survey, scanning roughly 100,000 galaxies for exactly this kind of unnatural infrared waste heat. They found nothing. 0 confirmed Type 3 signatures anywhere in the observable universe, which is either deeply reassuring, because nobody out there has eaten their galaxy yet, or deeply unsettling, because if it were easy to do, somebody should have done it by now. And the fact that nobody has done it might be telling us something about how this story usually ends. That unease has a name, the Fermi Paradox, and a Type 3 search is basically the most expensive possible way of asking it. Let's keep climbing anyway, because we have not even gotten to the centerpiece yet. At the heart of the Milky Way sits Sagittarius A star, a supermassive black hole roughly 4 million times the mass of our Sun. A black hole is not just a cosmic drain, it is potentially the single most efficient power source in the known universe, through something physicists call the Penrose Process, where energy can theoretically be extracted from a rotating black hole's spin by dropping matter into just the right orbit and letting some of it escape with more energy than it went in with. A sufficiently advanced civilization would not just build collectors around stars, it would eventually build them around the black hole itself, an accretion engine humming at the gravitational center of an entire galaxy, converting infalling matter directly into usable power at efficiencies no star could ever match. Now scale that idea outward. Imagine. And this is the actual climax of the Type 3 project. A fully mature Type 3 civilization is not one swarm. It is hundreds of billions of swarms, one wrapped around nearly every star in the galaxy, all networked together, all funneling energy and information toward processing structures called Matrioshka Brains, nested layers of computing shells stacked around a star like Russian dolls, each layer running on the waste heat of the layer inside it. The entire Milky Way, in this scenario, stops looking like a galaxy and starts looking like a single distributed machine. 400 billion processors wired together by light years of fiber and gravity, doing one continuous, impossibly slow act of thinking. So could a Type 3 civilization actually build this? Energetically, the engineering checks out. Every individual piece, the Dyson swarm, the stellar engine, the black hole accretion collector, the Matrioshka brain, is consistent with known physics. Nothing here violates a single law of thermodynamics or relativity. The catch is not physics, it is time and coordination. Disassembling one planet for a single star's swarm might take centuries, with hypothetical self-replicating von Neumann probes doing the heavy lifting, each probe building copies of itself to multiply the workforce exponentially. But coordinating that across 400 billion stars, most of which are tens of thousands of light years apart, where a single round-trip message takes longer than recorded human history, might require something more like a slow-motion biological process than an engineering project. A civilization that essentially becomes a part of its galaxy rather than a builder standing outside of it. And there is one final, uncomfortable wrinkle. The Milky Way is on a collision course with the Andromeda Galaxy, expected to begin merging in roughly 4 billion years. Any civilization patient enough to wrap an entire galaxy in solar collectors would eventually have to contend with that galaxy literally colliding with another one, stars getting flung loose, gravitational architecture torn apart and reshuffled. Maybe that is the real reason the sky looks so quiet. Maybe Type 3 civilizations are rare not because the engineering is impossible, but because by the time you are capable of building one, you also have the patience and the timeline to watch your own galaxy get torn apart and rebuilt before the project finishes. So the next time you look up at the Milky Way's pale band stretched across a dark sky, ask yourself what you are actually looking at. 400 billion suns burning freely into empty space, untouched, unharvested. Either evidence that nobody nearby ever finished this project, or evidence that finishing it was never really the point. But what happens when a civilization does not aim for one galaxy, but reaches for the energy of every galaxy it can see? That is a story for another What If.